Hello everyone and welcome back to day 2 of the egg experiment. So, a few things kind of getting us started just as a review. First and foremost, so today we're on day 2. You might have noticed that there are 2 sides to this page. We're really just focusing on the stuff that I'm going over each day. Now, furthermore, you had some options that I posted to Classroom and I mentioned yesterday, I think in like 2 videos, and a video that'll come out the rest of this week for this. I just made this sheet completed once. So if you are doing it with me, quote unquote, kind of live, like each day as it happens, because I like this experiment and I just wanted to do it. So that's why I'm doing like another round of it this year. So if you're doing it live with me, fill out your data with me. It's kind of fun to do it. So if you want to do this at home and you're using your own data, fill it out with your own data. You don't need to do my data and your own data. Just pick one. And you're probably just tuning into these videos just so you know what to do for the next bits and what's happening. If you're like, I don't know if I want to follow along live and I don't know if I want to do this at home, the assignment is on Thursday. So the actual assignment is Thursday. I have the videos all kind of condensed down onto one slideshow all together. So you'll just go through and it'll be everything all at once. It's your choice of what you want to do. Regardless, I need this filled out once. I don't need it for all the scenarios, all the situations, just once. So we're going to fill it in day by day. And then some people notice that there's, well, not a backside because it's digital, but a page 2. That one we're going to wait until we finish the front side. If you notice at the top it says define osmosis. Is that our assignment today? Interesting. It's like there's a connection. But seriously, there is. So we could answer that probably, I think tomorrow we'll talk more about it. We'll talk about it a little bit today. But in general, we just need to fill out the front side. And once we finish the days, then we'll go back and work on the back side. So with that, I'm going to move my camera back down here so that we have this information. So first and foremost, what you need to do is put the date that you are on for your day 2. Now, if you followed along with me and you started on Monday with me, your day 2 is going to be the 19th. If you're starting a day later, something else, well, then just put the correct date for your day 2, whichever. And then we can kind of set that aside for a little bit because we're going to take a look at our egg that we have here. So don't take it out of its vinegar solution quite yet, because I want to look at a few things. If you look right now, and you might have noticed this yesterday as things were already happening, there's this like foam at the top of the egg, which is like, what? Why is there foam on the egg? If I do kind of like a side view, right? There's that foam layer. You can even see some bubbles even still on the leg, or on the egg, not the leg. So what is that? Let's go back to about January when we learned about acids and bases. Vinegar is a what? Vinegar is an acid, right? Now, we also learned during that time that when we're going to have a reaction, acids are probably going to react with what? They're probably going to react with something that is basic, or it is basic in a solution, something of that form. That's what happened here. So we are using what we learned earlier in the year. I know you guys are like, oh, this is great. Some of you are rolling your eyes, but whichever. But we had an acid eat away the basic, or the shell that's on the outside, because the shell is made of calcium carbonate, which is kind of, well, it's the same thing that makes up shells of like sea animals or marine life. Oh, do you have a little flashback here right now? When we learned about rocks, we had limestone. And remember when we talked about limestone, if like statues are made out of it, or building sidewalks or buildings or whatever are made out of limestone, remember those can get eaten away because a lot of our rain is slightly acidic due to, global warming, climate change. We have other gases that are in the air that make the rainwater slightly acidic. So just like that acidic rain eats away at the limestone, just like vinegar is an acid, this acid has eaten away the shell, which is calcium carbonate. So that's the shell that we're seeing on the top, or the shell has been kind of dissolved away by that acid. So some things we can do is we're going to look at this, and first and foremost, you want to be careful with your egg. We're going to dump this out, but your egg is somewhat fragile. When we take this out, so when you take it out, just be gentle. Okay, does anyone else get like slight anxiety that things are going to fall down their garbage disposal? I do. So be careful with it. I usually try and just do that, and then I just give it a good rinse. Because I don't want to touch this tons. I mean, it's not like so fragile, like you're going to touch it and it's going to die or it's going to, completely undo itself. I just try to be very, very, very careful with it. All right, give your cup a good rinse out. And things you can notice. So we're going to need our cup here in just a bit. But some things you can notice. So where it says, what does our egg look like? What does our egg feel like? So I'm just going to talk about these and then we'll write them down here in just a minute. So our egg, it's like it has the outside, it's almost like you could see through the egg. It's also kind of squishy, right? And it's smooth, but you can kind of still feel there's a little bit of the eggshell is honestly still on here. So as you're rubbing it back and forth, I mean, that's just the eggshell that was dissolved in vinegar that's still kind of stuck on there. So if you want to give it an extra rinse off, you can. That's fine. Just be careful because, so our egg is squishy. It looks, I mean, it's still egg-shaped at this point. It's not bright white. It's more of a creamy white, so you can say that. Now, do you guys notice what I'm doing here? It's squishy, right? Like, why is this squishy? What we've done is we've eaten off the shell, but there's a membrane that's around our egg, or like the yolk and the egg white that's inside. Because, oh my gosh, can you see all the science going together here? An egg is like a single cell. The yolk is the nucleus. It really is. It's when, when a chick comes from this, that's why it has all those things in it. This is basically a single cell, and we have a membrane just like our osmosis video had. So this is the cell's membrane. Now, in osmosis today, we're going to be learning that osmosis is when water or a liquid passes through a membrane. Here's our membrane, right? Oh my gosh, you guys have like aha moments going all over the place. Maybe, maybe not. I'm going to set this down because I'm going to just wash off my hands a little bit, and then let's write down some of our findings here. And then we're going to weigh our egg, and we might be surprised. I mean, I just said we got rid of the shell. So do you think this is going to be lighter, or do you think this is going to be heavier? Don't write it down yet. We'll actually use our math. So things our egg looks like. So it's egg-shaped still. It is kind of creamy in color, creamy. Oh boy. Whiteout, I haven't used you in so long. So everything's been digital. Creamy in color, outside, almost see-through. So it feels like we can say that it is squishy. We can say that it has a smooth outside. Now, note, you want to be careful with this because even if you're like fingernail, if you have like a little, you know how your fingernails can sometimes have like a little, when they tear off or something, like your fingernail could actually go through the membrane. So that's why we want to be careful with it. But it's squishy, it's smooth. If you have anything else you want to add to it, anything else, I've always got a few people, as I'm looking at it, I'm like, I think I've got everything. But if you have other things you wanted to add to it, you definitely could. You could add the anything else, like the vinegar, which was acid, dissolved and calcium carbonate is CaCO3 shell, which is quote unquote more of a, like, it's basic. It's kind of like when we put things in solution for our acid-base lab, not necessarily all those things are found as bases, but when we put them in solution, or like vitamin C, the tablet, we put it in water, so then it was like an acidic solution. It's that type of thing happening. So now we get to the fun part. We need to see, has our egg gained or lost weight? So how I'm going to do this is I need to go to my scale. Now, if you do not have a scale at home and you're doing this at home, then either use my data and just look at your egg, or you can just be saying if it's heavier or lighter. I mean, I'd rather see some numbers of some sort. So if you don't have a scale, maybe just use my numbers, because you're going to get this, you should get the same results no matter what. But you might have also noticed. So just so it doesn't roll off this time, I'm just going to start it at 0. So put the cup on, start at 0, and then gently put my egg in. And the egg weighs 73.5 grams. What? So if we need to do a little bit of math here, 73.5 grams minus what we started with yesterday, which was our, yes, in fact, my calculator. So you could do this in your head, or I just always like to be double sure. So that comes to 17.5 grams is the difference. Now, we said, though, we lost the shell. In our feels like, we could say no shell as well up here. We lost the shell, so why is our egg heavier? It's because of osmosis, people. Osmosis means that liquids pass through this membrane, or water is able to pass through a membrane. Vinegar is not just acetic acid, which that's what makes up part of vinegar. Vinegar is made up of water as well. So some of that water, some of that liquid from our vinegar passed into the egg, because, so we've got this defined osmosis. So osmosis is a liquid, in our case it's going to be water, passes through a membrane. So then we have something called hypotonic and hypertonic. So hypo, you're going to, in the video, they talk about as being low. So that's a way to remember it. Hyper, high. So if we look at our roots and prefix here, so hypo, so wherever that is a lower concentration of solute. Hyper is where there is a higher concentration. Basically, osmosis, that water is trying to pass back and forth to go and basically try and dissolve out whichever area is going to be the hypertonic area, because whichever area is, hypertonic, so that they come to something called equilibrium. So with this, osmosis is a type of passive transport, and that just means that it does not need energy. So hypo, low concentration, hyper, high concentration. So wherever there is that higher concentration of something, that is where the water wants to go, because it wants to dilute it out, basically. So that's what happened with our egg, is that the vinegar was comparatively to the egg was hypertonic compared to so the egg is our hypertonic, the vinegar is our hypotonic, comparatively, at least to each other. So from the vinegar into the egg, it passed in because the egg is hypertonic compared to that vinegar. So what we're going to be doing today is we are going to be putting, oh, we got to answer our why. So our why, vinegar, water, or let's make this better. Water in the vinegar passed into the egg. I'm someone that likes to have a little bit of a drawing. So if you want to add this, you totally could. It's not expected. But our egg is hypo. So it's going to try and dissolve everything here. Because when we're looking at this, our egg, the nucleus and the egg whites can't leave the egg. So the only thing that can happen is the water can move into it and try and dissolve it out. So that's what's going to happen. What we're going to be putting our egg in for tonight now is we're going to be putting it in colored water. So first and foremost, just gently add, it doesn't need to be like super warm or super cold or anything, water. Just like put the faucet up, add that water, room temp-ish water. And then you need to add colors. And if any of you are on TikTok, it could be red, it could be yellow, it could be blue, it could be purple, it could be green or pink or black or what. Could be any color you like. Okay, I'm a bad singer, but you could choose any of those. I wouldn't use white though because that doesn't have color, so maybe substitute an orange. But pick a color, any color that you would like. Personally, you guys know me, I'm extra. I'm not going to just pick a single color. If you really know me, you know what color I'm going to go for. Got some blue because then I also need some red. And I guess maybe it would be better to put this in color your water first, because now I need to try and gently mix this. Because remember, I don't want to actually hurt my egg. Yeah, so add your color first, then add your egg. Mine will be okay, but yours will be even better. So, I'm going to have like that dip dye effect that people have been doing on TikTok. But that's okay. So, do that. We will check on our egg tomorrow. So, what we're putting our egg in is colored water. And we will check on this tomorrow. Have a great day, guys. Bye.